bottles, and then here is your here's your diagram for the low pressure fuel system, and you have a copy of this in your book. You'll notice I've left off the fuel rail, I've left off the injectors. The only thing that's high pressure in here is this side of the pump. Okay, but I want you guys to have a good understanding of the flow through this system. So we're going to go through each component, but just to give you an overview, we've got the fuel is obviously in the tank. Okay, once that gear pump turns on, it's going to draw the fuel through the suction side fuel filter, through our priming pump circuit. Okay, whether this pump is on or off makes the difference as to whether it's going here or around the pump. We'll talk about that. Through the gear pump to the secondary fuel filter. Okay, after that secondary fuel filter has cleaned all the fuel, it is then transferred to our high pressure pump assembly. Okay, this is where things get a little bit complicated, and this is where there's lack of understanding in the industry. And I want to make sure you guys all have a good understanding of what's going on in this pump head. Okay, because this is very important. Now we're going to send fuel around the pumping plungers. We're going to send fuel through an air bleed orifice back to the tank. Okay. The ISB does not have a priming pump, so we'll talk about that as well. And we're going to go through the Cummins fuel system, and then I'm going to show you the difference with an ISB. Diagnostics are exactly the same, with exception of one single test. Okay, so we're gonna discuss all this. So here is your low pressure system. Everything is delivered back to the tank. Anything that's not put into the pumping plungers is headed back to the tank. Okay, so we'll get a good understanding of each of these components on the next page. If you flip over to page 3, you'll see a chart. Okay, the chart looks something like this, and you'll have all 7 of your components listed, starting with the fuel tank. Okay, I want you guys to write in the blank beside fuel tank. I want you to write anything that's important about that fuel tank. So can anybody tell me what some important things about the fuel tank are? Some things that maybe if it wasn't true, you might have some issues with your fuel system. What's required of the tank? I'll give you a hint. It's got to have fuel in it. Okay, if it doesn't have fuel in it, we're going to have some issues. Okay, what else?
The tank has to vent?
Good point, Jordan. Okay, the tank has to vent. Why does the tank have to be vented? Because we're relying on that atmospheric pressure on the top of the volume of fuel. Okay, if we didn't have a vent here to allow atmospheric pressure in, once this gear pump starts running, we're going to start to create a vacuum in here. And that vacuum is eventually going to prevent the flow of fuel through the suction side of the system. Okay, so that tank has to be vented. And I have seen at a Cummins shop, I might add, a diagnostic for a low rail pressure fault, which resulted in the changing of this high pressure pump, the entire assembly. We're talking thousands of dollars, and it was in fact a plug tank vent that was the source of the low pressure fault. Okay, so I've seen that, and probably it's happened a billion other times. The problem is that the guy saw a low rail pressure fault code. He said, "Yeah, I've seen these pumps fail before." Threw a pump at it, and all the while he just had to clean the tank vent off. Okay, so it's unfortunate, but if you cover your basics first, then you will avoid replacing a pump that does not need to be replaced. Okay, venting of the tank is very important. That should be one of those initial checks that you do. If you have a problem with low rail pressure or stalling or something like that, you could even just pop the cap off the tank and see if the problem goes away. Okay, so atmospheric pressure must be applied to the contents of the tank. Good. So that's about it for the tank. The 2 important things: one, it's got to have good fuel in it, and then 2, it's got to be vented. Okay.
Can I add something quickly?
Yes, sir.
Okay. What I see, because I'm in like the north, so I see a lot of snow, and the Alaska guy might see this too. I just had one on a Volvo the other day. I see them plug up with dirt all the time, and I've even seen ones on a Cummins with a Peterbilt that someone installed a tank, or this is from the factory, because the factory makes mistakes also. Someone put the vent under the tank strap and pinched it. So it is very important when changing the tank to be very diligent about that vent.
That's right. Yeah, if it's not vented, you're going to have fuel system issues. You're going to have stalling, low power. Even just if it's not fully plugged off, even if there's a restriction, right? At full load, we may end up with a fault because we have enough restriction that we're not getting enough volume of fuel delivered to our high pressure pump. Okay, so these are some things to consider right off the bat. That tank vent seems like such a small thing, but it's very important for the proper operation of our low pressure fuel system. Good. So that's number one. Number two is going to be the primary fuel filter. This is the suction side fuel filter, also known as, and that's because we have a vacuum on this section of the this is the suction side of the pump. Okay, this would be the pressure side of the pump. So suction side fuel filter, also known as the primary fuel filter. Can anybody tell me what the micron rating typically is for a suction side fuel filter? Anybody ever looked?
I mean, like 5.
Okay, 5. You might see 5. Typically, this one here is going to be 10, 25. I've even seen 100 on some Detroit product. But for Cummins typically uses a 10 micron filter at the suction side of their system. And they're going to say it's got to be a Fleet Guard filter. Who installs this filter? Does Cummins install this filter, or does the OEM, vehicle manufacturer? This one is going to be somewhere installed by the vehicle manufacturer. So hopefully it's in a place where you can reach it. So this is an OEM thing. So it should have also another note you need to make. It should have, according to Cummins, it should have a water and fuel sensor. It should have a drain and a water separator. Okay. Those are the 3 requirements. You may also see some of them that have a heater, an electric heater built in as well. Okay. So these are just a few of the things with that suction side fuel filter.
Is that the Davco filter that we're talking about?
Yeah, possibly. That's whatever the first one is. It's on the OEM line between the tank and the actual engine. Okay?
Generally speaking, from the trucks that I work on, I'm thinking we're talking about the one on the frame rail.
Yes.
And sometimes they're cooled or they're heated by coolant, right?
Could be. Yep. Depends on the manufacturer. It depends on the OEM,
electric
right? The
also?
OEM. Yep. There could be electric heater as well. So they could be heated some way. It depends on the environment that you're in, and whatever the OEM decides to put on it. Okay.
So the heater is a very simple electrical component.
Typically, yes.
Power and ground. So I can unplug it, stick a sealed beam light in there. If my sealed beam light is nice and bright, then that verifies circuit integrity also.
Yep, you can do, or just a resistance check on that heater itself.
Yes, but a resistance check isn't checking the circuit loaded. When you were checking electrical, I always like to make sure that I'm checking it loaded. Yep. You know what I mean?
Yep.
That's just my preference.
Mm-hmm. Yeah, it's just a twisted. It's just a heater circuit though, right?
Yeah,
it's just
a coil of wire.
A big resistor. Okay.
Yeah.
So you may have that. You may also have a coolant one as well. So that's very likely also. Depends on manufacturer. So that's all up to the OEM is the point here. And the OEM is going to decide where to put that filter. Okay. So that's the suction side fuel filter. Again, 10 microns is typically the what you'll see from a Cummins engine in terms of micron rating. And that's important to understand that in comparison to your secondary fuel filter that we'll get to. Okay. That brings us to the lift pump and the lift pump bypass check valve. Now, this circuit here, what I find in the industry is that it's not very well documented or not generally known that on a Cummins fuel system, there is a bypass circuit included in this in this priming pump. Okay, so I'm going to show you a couple things that can possibly go wrong. But this priming pump, it will turn on in the Cummins world. It will turn on at engine key on. Okay, so at key on, the lift pump will run for either 30 or 60 seconds at key on. Okay. Then once the engine starts up, there are some calibrations that will command this priming pump on once again for an additional 30 or 60 seconds. Okay. Once this times out, it's off for the remainder of operation. Okay. So one thing to keep in mind, because there are some out there that think that this priming pump runs continuously during vehicle operation. It in fact does not. Okay, on these platforms, this priming pump is strictly there just to prime the system. It does nothing to do with the normal operation of the fuel system. Okay, so when we key on, the priming pump draws the fuel from the tank through the suction side fuel filter, delivers it to the gear pump. Inside the gear pump, we'll see a bypass circuit. If this gear pump is not running, the fuel bypasses the gears to the pressure side fuel filter through our cooling circuit, through our air bleed venturi orifice back to the tank. Okay, this priming pump, once it shuts off, the gear pump is going to actually draw the fuel through this bypass check valve. Okay, once this pump stops running, it becomes a high restriction. Okay, so the gear pump doesn't. We want to avoid the gear pump drawing the fuel through the priming pump when the priming pump is not running. Okay, so what would happen if we had a priming pump bypass? Let's say that we had a bypass lift pump or lift pump bypass check valve that was plugged. Let's say that we pre-filled this suction side fuel filter and we had a giant piece of dirt or debris or something like that got sucked into this circuit here and plugged off this passage. What would happen when this priming pump turns off? Is that going to affect the operation?
Would fuel flow through the priming pump? No, right?
Not enough. I'll tell you that right now.
So
okay, this priming pump is, sorry?
Can I stick a gauge at the outlet of the priming pump to compare pressure to the inlet? And if the pressure is significantly lower, that means that there's something wrong with the check valve for the bypass?
Well, you can't really. What we're going to do is actually look at what our gear pump pressure is in order to diagnose that. We don't want to hook up any gauges down here other than a vacuum gauge. Okay? So this priming pump here, if this lift pump bypass valve is plugged, and I've seen this before, if this circuit is plugged up, we're going to end up with a stalling condition, okay, or a low power condition. Okay, so these are the two conditions that may be that may be a result of this being plugged up. Now, this check ball is actually included in one of these little quick connect fittings on the lift pump circuit itself. Okay, so it's integrated into one of the quick connect fittings. You'd have to refer to QuickServe to figure out which one it is. But there is a check. This check valve is incorporated into one of those fittings. Now, here's the other scenario. Let's say that the spring inside this check valve fails and this remains open all the time. What's going to happen is when I try to prime the system, the priming pump recirculates the fuel within itself, okay? Because there's a higher restriction through here than there is through here, okay? This would result in a lack of prime situation. And I can't imagine that any of you have ever experienced a difficult to prime situation on a Cummins fuel system, okay? It happens all the time, right? You flip the key a whole bunch of times and still, like, it takes forever to start the thing up. We actually have to start cranking it to get the gear pump to take over in order to get enough fuel to the high pressure pump. Okay, so there's a possibility that this spring in here, I was told it's made of frog's hair. Okay, that's how unreliable it is. This guy right here, if it fails open, then we're going to end up with a priming pump that really doesn't do anything other than recirculate fuel within itself. Okay, so that's some good information there on this priming pump. Could result in, I've seen it result in a, the engine starts and it runs fine. And I can move the vehicle reliably for the first 60 seconds of operation. Once that lift pump turns off, whenever I try to move, the thing stalls. Okay, I've seen that before because this passage was plugged up. And what we ended up finding in there was the rubber from a banjo fitting seal. Okay, because the banjo fitting seal that they used on the system when they last serviced it was actually for a cooling system and not a fuel system. Okay, so keep that in mind. There are banjo fitting seals or washers that are designed for fuel system, and there's different ones that are designed for cooling systems. They're not compatible. They're not interchangeable. Who would have thought? Okay, so that's about it for our priming pump circuit. Just keep in mind there is that bypass check valve in there that could cause you some issues on your ISX, ISC, and ISL engines. The ISB doesn't have a lift pump. Okay, so we don't need to worry about that for the ISB in our heavy duty product. Okay. That brings us to our gear pump. So I mentioned that if that gear pump's not spinning and that lift pump is on, there is a bypass check valve in our gear pump, so that we're not trying to push all of our fuel through the gears of the gear pump. Instead, they bypass. Okay, so there is an internal bypass check valve in our gear pump. That's an important thing to note. If this thing were to be plugged up, it's going to result in a lack of prime situation. Okay, so there's another possibility of a difficult prime situation. Okay, this gear pump also is internally regulated. So there's an internal regulator as well in there. Those are a couple things that you need to note. And can anybody tell me where this gear pump is located?
Back of the high pressure pump.
Perfect. So on the back side of the high pressure pump, it is mounted directly off the back of the high pressure pump. And that high pressure pump, the cam inside that high pressure pump is what drives that gear pump assembly. Okay, so it is constantly during normal operation, this thing is spinning, regardless of how much fuel we need to put into our rail. Okay, so we're constantly circulating fuel, and there's good reason for that as well. Okay,
is there a bypass check valve inside the gear pump also, plus the priming pump? So there's two bypass valves?
That's right. So there's a bypass circuit for our priming pump, and then here's the situation. If you just turn the key on, the gear pump's not spinning because the engine's not rotating, right? So if we didn't have a bypass valve in here, then the priming pump would have to try and push all that fuel through the gears inside of our gear pump. That would be too high of a restriction. So this is an additional bypass check valve for priming when the engine is not rotating. Okay.
Can that, like, is there a, I want to get all possibilities here when I'm doing a diagnostic. Can that bypass valve be stuck on, let's say, and the gear pump doesn't operate because it's stuck to the bypass valve? Is that a possibility?
If that bypass valve were stuck open, I would doubt that it would have, like, this gear pump is going to be spinning and delivering the fuel to the high pressure pump. I doubt that it would make much of a difference if this was stuck open. If the regulator were stuck open, though, that's a different story. Okay, that would cause low gear pump pressure. Okay, but this bypass check valve, where it's going to cause problems is when it's stuck closed. So if you were to take all this stuff apart and put it back together and leave a piece of dirt or something like that in there, and it sees this thing closed, or plug this passage, right, then we're going to end up with a lack of prime situation. Okay.
So is there, like, this regulator? I'm guessing later in the course you're going to be teaching us how to diagnose.
Yeah, you're going to know how to. The idea is that by the end of this, you're going to be able to take your gear pump pressure readings, and then you're going to make a decision. Do I have a problem over here, or do I have a problem up here? Okay. Then if you do have a problem down here, I'm going to show you what tests you can do to eliminate, by process of elimination, you will point to that gear pump.
Okay, so now, the regulator, is it adjustable?
No, it's not adjustable.
Okay,
this is all integrated. If anything goes wrong inside this gear pump, you replace the entire gear pump. Okay, so there's not really
change the whole thing.
Yeah, that's right. There's not really any benefit to you knowing what went wrong in that side, that gear pump, because you can't replace components individually. All you need to be able to do is isolate to say that yes, this gear pump is bad.
So now I know I'm jumping the gun here in the course a little early, but when those gear pumps fail because there's, like, liner problems or something, you have to replace the engine oil multiple times to make sure you got no fuel dilution in your oil, right?
The gear pump has nothing to do with the oil system. Okay. There's no interchangeability with oil and the gear pump. Okay.
Isn't there another pump?
When it comes to our high pressure pump, we'll find out where the oil and the fuel might be able to meet. Okay. So we're going to get there for sure. The gear pump, nothing to do with the oil system. Okay.
Perfect.
So the gear pump itself, there you go. There's a picture of the gear pump on the back side of this high pressure pump. And again, that's going to run continuously during key on. So as this gear pump is running, we're circulating fuel through this, what is called the cooling circuit, and through the air bleed venturi orifice. We'll take a closer look at that later, okay? That brings us to our secondary fuel filter. Now, does anybody know what the micron rating is of a secondary fuel filter?
5.
5 micron or better. Okay, I'm seeing 3 in some industrial product. We're seeing 2 micron filters. Okay, 2 micron is roughly the size of a single bacteria. Okay, I got a question from Jason. Does ISM have an oil seal between the gear pump and fuel? The ISM fuel control module, yeah, that's different. That's not a high pressure common rail. Okay, so yeah, there is some oil relation there on the X and the M engines. Okay, so 5 micron pressure side fuel filter or secondary filter. We're going to talk about microns later. Very important that you understand some key things that you need to write down beside this filter is one, the most important one ever. Do not pre-fill your secondary filter. Okay, and I know that probably 99% of you are thinking, oh shit, we do that all the time. Yeah, everybody does it all the time. I want you to stop doing that because that's the number one cause of pump failure. Okay, so if you can avoid pre-filling that pressure side fuel filter, do not pre-fill the secondary fuel filter. Okay, good. So do not pre-fill. If you look at the service manual, you will see that Cummins specifically says do not pre-fill that secondary fuel filter. Okay, so the secondary fuel filter, it is 5 micron or better, 5, 3, 2 micron in some cases I'm seeing. Do not pre-fill it. And also the filter head is where we're going to do all of our low pressure system diagnostics. Okay, that's another important thing. This is where we're going to tap into the system to determine if we have a low pressure fault or a high pressure fault. Okay, perfect. So that's
where that test port is. Like, there's that really common
yes, sir.
diesel engine test port. I have
one. The CompuCheck fitting. Yes,
I have. Yeah, that's what it's called. I have a CompuCheck fitting on a big long hydraulic hose so that I can run it up to the windshield if I have to during a road test. And then I have a digital gauge that I plumb into it. So that's what we're talking about.
Yeah, we'll show you how to do that. Now, tapping into it on a mid-range engine versus an ISX engine, it's a little bit different. We're going to see some photos of how to do that. Okay, so you guys are going to be all in the loop on how to hook this stuff up and what's required. Okay, so Jordan mentioned he's got a gauge. That's good, and he's got a whip for that gauge so that he can extend it. The thing he probably doesn't have is the 43 thou diagnostic orifice, which is a requirement if you want to do any low pressure system troubleshooting on a Cummins diesel engine. Okay, and that's the part that's always missing, but it is essential for any troubleshooting. So we'll get to that.
Are you going to give us a part number for that by the end of the course to buy?
Yes, you'll have a part number for everything that you need. In fact, I'll give you, I'll let you know of a place where you can buy a Cummins fuel system test kit made by yours truly. Okay, so I'll let you guys know what tools you need, and then you'll have the opportunity if you need any of these tools, if you want to source them, I could potentially provide those to you. Okay,
thank you so much.
Secondary fuel filter. This is a picture of an ISX secondary fuel filter. As Jordan mentioned, I don't know if it's big enough for you guys to see. There is a CompuCheck fitting here, and there's another one right here underneath this rubber cap. Okay, so there are 2 fittings on the ISX. This is where we're going to tap in. You can also take this plug out and you can tap in there as well. Okay, so we're going to take a look at this closer as we go through the training. And then that brings us to our high pressure pump or fuel pump actuator and actuator housing. Okay, so we are on component number 6 is the fuel pump actuator and actuator housing. Before we talk further about this fuel pump actuator and actuator housing, I want you guys to understand the components in relation to our diagram. Okay, so here's our high pressure pump from an ISX engine. And the first component that we're going to touch on here is this supply line. Okay, this is where our gear pump fuel enters the high pressure pump assembly. This special banjo fitting here, if you've ever seen this, it's got like a little top hat on it. That has a screen inside of it. It's an 86 micron screen. And this is the last line of defense. If you pre-fill this filter and you leave paint or something in there or dirt, it might get caught up in this screen. Okay, there's a possibility that this screen could even plug up. The things that we were finding in these screens, most notably, are banjo fitting seal components. Okay, so we were replacing our banjo fitting seals on some of these components, and they're degrading because they're not compatible with diesel fuel, and then they end up inside of this filter here. Okay, so there's a screen inside of this fitting. You can't replace the screen, replace the entire fitting. If you guys do any service, I would recommend you get a new fitting with a screen, and make sure that that is brand new and fresh when you reinstall things. Okay, so not overly common, but there is a screen there. It's a last line of defense, but it's only 86 micron, and this guy here is 5 micron typically. Okay, so there's your inlet to the pump, and then here's your fuel pump actuator. Okay, so I want you to make a couple notes about this fuel pump actuator. One, the actuator determines how much fuel goes into the rail, essentially. Okay, and it is normally open, meaning if I unplug it, it goes full flow. Okay, so it is pulse width modulated, normally open valve. And it meters the amount of fuel going into the pumping plungers of the pump. Okay, it's also known as, I call it a fuel pump actuator. You might hear it called an inlet metering valve or a fuel control valve. Okay, there's different names for it, but ultimately what it does is it takes the flow from our pump and redirects a portion of it into these pumping plungers. Okay, that's all it is. So if this thing is closed, how much fuel goes into my pumping plungers? If it's fully closed, 0. Okay, there is no fuel if this thing is fully closed. Okay, good. So that's our fuel pump actuator. Here's our fuel pump actuator housing. Now, I want you to make some notes about this fuel pump actuator housing as well. This is responsible for directing our gear pump fuel through these two special circuits. Okay, this one here is a cooling circuit for our pumping plungers. Okay, this one here is an air bleed or venturi orifice. Okay, this creates flow through back to the tank, which draws fuel through this cooling circuit. Okay, very important. So this little piece here serves a very important purpose. If this is plugged or restricted, it may reduce the flow through this cooling circuit, which results in these plungers potentially overheating. The barrel and plungers potentially overheat, seize up, and fail. Okay, so it's very important that we don't plug these up. Where could contamination possibly come from if I have a 5 micron filter in place?
When you change out that actuator housing?
Or when you change your fuel filter and you pre-fill it, right? That's more common. That's a regular maintenance item, and that's what's potentially causing failures of our high pressure pump. Okay, pre-filling of that filter, some of those contaminants may enter the actuator housing, restrict some of the passages, resulting in a pumping plunger failure, resulting in a low rail pressure fault code. Okay, or worst case scenario, the engine seizes up because some of these filings end up in the oil portion of the pump and they get recirculated back into the engine. Okay, so very important, this fuel pump actuator housing, it directs fuel through our cooling circuit and our air bleed venturi orifice. Okay, and we'll take a little bit of a closer look at that later on. Then we've got our pump head. That's the top part here. You can see there's some check valves in there. The barrel plunger assemblies are threaded into this pump, and we'll see another picture of that later on as well. And then here's our pump body. This pump body is oil lubricated. It houses our cam, which drives our barrel plunger assemblies. Okay, so the bottom end of the pump here is lubricated with engine oil. Okay, so we have a couple of cams. So Jason just wrote that in the chat there. There's a couple of cam lobes here. They're triangular cam lobes. And these are lubricated by engine oil. You are correct. So there's an oil passage through the front gear housing. Okay, that goes into this assembly here, which lubricates the bottom end. that cools and lubricates our pump cam gear, okay? What lubricates our barrel plunger assemblies? What cools and lubricates the barrel plunger assemblies? We just mentioned it. Fuel. Good. So we've got fuel on the top end. We've got oil in the bottom end. So is it possibility that you need to that you could have some oil in fuel issues related to the high pressure pump? Okay. Jordan asked if you need a wrench. And a wrench to remove the barrel plunger assemblies. That is not a procedure that is allowed by Cummins. If you guys are taking this pump apart, replace the entire pump. Okay, do not put it back together. Do not put it back into service. Otherwise, you're going to have a vehicle that's on the side of the road. Okay, and we'll find out why in a little bit here. Okay, so yeah, you're going to replace the entire pump. Okay, so CP4, is it oil lubed or fuel lubed? So for any high pressure pump, a high pressure common rail pump, you're going to have oil. Like even on the ISB engines, there's oil going into the pump for the cam and then going out of the pump. But the barrel plunger assemblies are always fuel lubricated. Okay, so that we're not pushing oil into our fuel rail. Okay. So for when it comes to these pump assemblies here, I'm going to recommend, just as a best practice, do not replace individual components if you can even get them. Okay. The only thing maybe to replace individually is this gear pump here. Okay. So that's a general rule, is replace the entire pump, and we'll find out why as we go along. Okay. So that's our high pressure pump, our gear pump, our actuator housing, and our fuel pump actuator. Okay, so here's a closer look at those passages. And I've got a barrel plunger assembly to show you guys in a little bit here. But we've got the inlet. Okay, we've got this actuator housing that is distributing the fuel through our cooling circuit. And then here's the return back to the tank that comes off the top of the pump. Okay, so this goes back to the fuel tank. Perfect. There's our fuel pump actuator. We already took some notes about that. So this is just a closer up view of what's going on here. So if this actuator opens up, we allow some of that fuel to go into our inlet check valves. If we have fuel going in here, it pushes our plunger down. Our plunger comes back up when the cam presses on the bottom side of it and pushes that fuel out to our fuel rail. And we'll look at that closer when we talk about the high pressure components. Okay. All right, now the last component. So we got lots of questions in the, is the pump return fitting regulated? No, it's not. Okay, there's no regulation on the return lines. The only return that has regulation is the injector return, but it's not adjustable, and it's just incorporated into a banjo fitting on the back of the head. We'll talk about why later on when we talk about high pressure side. There's no regulation on the return lines. Okay, so there's no regulator in here or anything like that. So basically, we're constantly circulating. The idea is that we're consistently going to circulate fuel from the tank all the way through the system back to the tank constantly, regardless of how much fuel we need to inject. Okay, this is constantly happening. Okay, and that's to cool our pumping plungers, and that's for air bleed purposes as well. And then the pump actuator is going to open up, take a portion of that volume, add it to the rail. That's all it's doing all day long. Okay. So ultimately, this low pressure side runs unregulated by the engine control module. There is no electronic components at all on the low pressure side, other than our fuel pump actuator, which essentially just takes a portion of it and directs it into the pumping plungers. Okay, so we should have consistent flow through this assembly. And the last component is the fuel drain manifold. So this guy right here, this fuel drain manifold, the only reason why you need to know about it is because on our X, L, and C model engines, we can do our diagnostics through this return line. Okay, there's diagnostic advantages to being able to access this. The problem is that it's typically not accessible. Okay, this is down on the left-hand side of the engine. nowadays, like tucked back, like if you have a doghouse, you might be able to, if you can access through the doghouse, you might be able to access it. But for the most part, this is buried, and it's not going to do you much good personally as a technician working on today's vehicles. Okay. But it's important to know that it's there. And this return manifold does not exist on the ISB engines. Okay. All it does is take all of our returns and route them back to the tank. Okay. So 3 banjo fittings right here. We'll take a closer look at that as well in a little bit. I think actually I might have it on the next slide. There it is right there. Okay, so we've got our main return line back to the tank. We've got a rail pressure return line. We've got an injector return line, and we've got a pump head return line. Okay, all this goes back to this manifold and gets redirected back to the tank through here.
So, quick question here.
Yep.
The 6.7 Cummins, like found in a Dodge pickup or like a delivery truck,
Yep.
Does this have a similar system?
Yeah, the fuel system on the Dodge product is exactly the same, other than the fact that their fuel pump is in the tank. Okay,
The lift pump is in the tank.
Well, it's the fuel pump. Okay, the gear pump essentially the gear pump portion is typically in the tank. Okay, and it just delivers it to the high pressure side. Other than that, it's the same problems. Okay, you have the exact same problems, so it doesn't matter what. As long as it's a Cummins ISB, right? It's still got a high pressure pump, and it's still got a low pressure system that has to be able to deliver fuel to the high pressure pump.
So a high pressure pump on like a Dodge half ton with a 6.7 in there, Dodge not half ton, 3/4 ton or 1 ton, in the 6.7 is all built into the sending unit on top of the fuel tank.
Potentially, it depends. It depends if it's a Dodge. The problem is once you hit like a, I think I can't remember at what point it becomes a Cummins heavy duty. Obviously, 10,000 pounds or greater gross vehicle weight.
A box truck in like an international would be different.
Yeah, exactly.
It's then a 1-ton truck with a box on it, right? Like a pickup truck box.
Automotive ISB engines will potentially have the gear pump, the pump, what we call the gear pump would be integrated into the sending unit in the tank. Okay. So that's where the flow starts. So if we look at our diagram here, like this gear pump would just be in the tank right here. Okay. We wouldn't need this potentially. Okay. And then it would the fuel would flow from here through the suction side, or through the first fuel filter, through the second fuel filter, or through one fuel filter. Probably the suction side one is going to be included as a sock on the sending unit here. Okay. And then out to the high pressure pump. Okay. So I can't confirm or deny which models have which version. The point here is that we have 2 portions of the system. We got the low pressure system, which has to deliver fuel from the tank. I don't care how you do it. You got to get the fuel from the tank, clean it, and deliver it to the high pressure pump. Okay. So there are differences. There are some differences depending on what vehicle it is and what the gross vehicle weight is, and whether it's a Dodge or a Freightliner or whatever. It doesn't really matter. Ultimately, we have to have a low pressure side and a high pressure side. Okay, so your diagnostics should ultimately be the same, okay, or very similar. Okay. So we have on the bottom of page 3 here, low pressure system must deliver sufficient volume of fuel to the high pressure pump. Faults in the low pressure system can cause fuel rail pressure fault codes. Okay, so low rail pressure fault codes could be a result of your low pressure system. Okay. So unfortunately, what I sometimes see is that when you see low rail pressure, some technicians automatically think fuel injectors, high pressure pump, right? When ultimately what could be wrong is you could have a plugged tank vent. You could have a restriction in the suction lines, right, causing a high inlet restriction. So there are things on the low pressure system that can cause problems on our high pressure side. Okay, and we'll talk about that more when we get to the diagnostic portion.
Okay, quick question here before we move on.
Yep.
Now, cold weather, which we would see, especially me and the Alaska guy, you can have like fuel freezing up, slushing up, like, gelling up.
Yep.
So what we do a lot of times to prevent that is we'll use fuel conditioner.
Yep.
Can
Yep.
fuel, like, I understand pouring a jug of methyl hydrate in there would probably cause damage because it's got the volatility is way more extreme than diesel fuel per se. But when you put fuel tank conditioner, that would have lubricity additives in it to prevent damage to components such as a high pressure fuel pump. Correct?
Use only approved anti-gel agents or additives. Only
Where do we
approved
find
additives.
that? From Cummins?
And yes, from Cummins, and it'll probably be some Cummins branded thing that they're going to recommend, right? But don't go to any shelf in Canadian Tire and just pick whatever you find. We're going to talk about the reasons why there's only certain approved additives, and it's going to be very clear why. Okay, so we're going to talk about that a little bit more. But you need to use approved additives in the right quantity in order to avoid any failures. Okay?
So the clean flow that I've been using is no good. I have
no idea. I'm not going to. I can't confirm nor deny that what you're using is correct or not. Okay, but you got to make sure that you refer to the manufacturer. Otherwise, you may end up causing problems, and we're going to find out why after we take about a 5-minute break. So we'll see you guys at a quarter after. Just when you get back, just throw your cameras on, and then we'll get started. In the meantime, here is a master notes list. If you missed anything or you want to change anything, here's what I have here. Okay, so we'll see you guys back here in about 5 minutes.